So the next thing, the subset function. This is really useful. I generally sometimes use the dplyr version of this, but I want to start and learn, and I'm doing this for a reason. I just want you to learn the base R functions that do these different things, unless there's not a good replacement. Like case when I went to the dplyr version because this base R version was not a good choice. But I do think that learning the base R functions, even if they are a little less easy to use, is important because a lot of people still use them and you're going to need to know how to use them. And that's the most basic thing. If you don't want to use a package, people use them. So I want you to be able to, if someone hands a piece of code to you that's written in base R, I want you guys to be able to understand it. People who've been coding longer than I have, my coworkers at work who have been data scientists for many years, they generally only use base R because they're not used to dplyr or tidyverse. So there is a method to my madness, I promise. And if there's not a good replacement in base R, I will always now teach you the dplyr tidyverse version. So subsetting. If we are going to subset this shows you how to subset using the values in our data set. So it's really similar to what we just saw. One thing that I need to mention now that I'm showing this here, it's very confusing, especially if you've never seen it before. Now that I'm seeing it, I forgot to explain it in the last slide. So similar to what we saw before, this subset function, your first argument here is going to be world.df, and then we have our rule, just like we had before. It's HDI.level, and we're going to say equals low. This is the part that I didn't explain last time, because this is the case in all of our rules. So there are two types of rules, or you sometimes will use one equals sign, and sometimes you'll use a double equals sign in R. Okay, the single equals sign, you would use that only when you're assigning something. So I'm going to go in real quick and show you what I mean by that. So we're going to say state equals and Texas. Okay. Now let's print state. It equals Texas. So we just like we did and always have before, we use this assignment operator. However, if we wanted to do state 1, and then you could also use an equal sign here, a single equal sign. That is very important here. Okay, so state 1 and then a single equal sign is the same, or it's equivalent to this operator here. So say we're going to do Pennsylvania. So you'll see when I print state 1, it equals Pennsylvania, just like you would expect it to. So this works the same way as this. However, if I do state 1 equals Pennsylvania, it will return true. So this is what I mean by the difference. So we have that single equal sign here, and we set it equal to Pennsylvania. But what I'm showing here is a rule. We are basically doing the same thing. We were asking the computer if it's true that state 1 equals Pennsylvania. So you use equals when you want to know if two things are equivalent, and you use the equals for assignment. As a general rule in data science, rule of thumb in R, people recommend that you always use this as the assignment operator. Why? Because these two it is very confusing when to use one equal sign or two, and also it's really easy to make typos. So that's something to keep in mind. I have had my code fail many times just because I knew I should have used the equals, but I typed 1 instead, and it errored out. So that is a good thing to keep in mind. Go in and look at the questions. Are dplyr functions for subsetting faster than base R functions? Yes, the answer to that is yes. Dplyr functions are built, I believe, on C++. I'm not sure what base R functions are built on, but in general, the C++ version, Dplyr, tends to be faster than the other versions. So that's a good question. And one thing also that's interesting that just came out that I was super excited about. So as you guys know, when you probably know that when you use bigger data, you sometimes need to use different functions. So the dplyr is faster than base R, but there's something called data.table or data table that is even more fast than dplyr. It's faster by a lot. So if you have, I say, 2 million rows and you want to subset your data, you would want to use, for the most part, data table. But data table has some funky syntax. It's like indexing, but different and a little bit confusing to write. So you have to basically learn a whole new set of functions. Something just came out that allows you to run data table with dplyr syntax. So this is something that's worth Googling because I forget the name of the function. New R package. So dtplyr is now, they just created this. It's brand new, so there might be some bugs. Or there was a version, but it was not useful because they didn't do a good job with it. Well, now they have a whole new version that works really well. Let's just click on this. So you could go here to get see how it's built, but this is data table with dplyr syntax, which is great because data table works so much faster than even dplyr does if you're using big data. If you have a small data set, it's not going to make any difference. All right, so that's good to know. I learned about that this past week. A coworker let us know that. So that if you use big data, always use data table because it's a lot faster. The reason for that is data table parallelizes things. So it's running your data on multiple cores on your computer. Yeah. All right. Back into here. So now that I've explained this equals here. So as I said, in the subset function, the first argument is world.df, and then you put a comma, and then you put a rule. If this rule is true, it's going to keep it in your data. So this will keep all values that where the HDI level equals low and remove all other values. So that's what, and our rule is basically HDI equals or is equivalent to low, and everything else will be removed. Now there's a different way to write this, or to write something different. So I looked at high corruption here. So the lower HDI level values are actually equivalent to high corruption. So in this case, we're going to make a low corruption. So we are going to subset world.df, and then I wanted to show you this operator. So if you want to say not equals to, then you can put not equals to low here. So this is going to remove all values where the HDI level does, and this should say, I don't know what's going on there, does not equal low, and keep all other values. I'll put this online, the updated version. So, all right, so that operator here is not equals to, and this is equivalent to or equals to. All right, so this is going to show you how that works. So now let's just do number of rows, high corrupt. We had 225 values before, now we have 94. I think your next question is probably would be, can you do multiple rules at the same time? The answer is yes, you can. Okay, so I'm going to give an example of that. Using multiple rules with subset So in this case, let's go and see what else we can do here. Let's look. I will subset it to the HDI equals low and high population growth. Or actually, I will pick something here instead, just so you can see what it looks like with a numeric value. So we will put corruption rank over 50, just so you can see that you can use mixed data types here. So we will put high corrupt, and then so high development. So use that subset function. We got our world.df. We can write our first rule here. So HDI level equals high. And then we always would put the and if we want to use multiple, or you could use or. In this case, we'll use and. Or actually, let's use or because that's a thing that you need to know. So this up and down bar always equals or. So what this would mean, let me finish this. So HDI level equals high. And if we go in, we'll use the corrupt percent rank in this case, and I'll put equals or greater than 50. So we have in this case, if a value this HDI level equals high, or the corruption percent rank is greater than 50, if either one of these are true, it's going to keep it in our data set. So let's go in and just do number of rows, high, core. We have 182 rows in this case. So it got rid of a couple dozen rows. So that's how you would do two rules, and that's also how you use the or operator. One thing I do recommend, if you use, say, any mathematical calculations in here for some reason, always put parentheses around your rules, because order of operations are always going to matter here with mathematical concepts. All right. Are there any questions about the subset function? I'm going to go on to how to select variables in a second. So if you have a question about that, hold it. All right. So the subset function also has another use. They're keeping or removing variables. So this subset function, you can use, in this case, we're using world.df again. And we are selecting a subset of our variables. So our world.df is a very, very large data set. It's got a lot of columns. So if we want to say pass on some results or some information to a stakeholder, we're not going to want like 50 columns in our data set. We're going to want something smaller. Say we want to focus on just the corruption variables. That's all they're interested in. So in this case, this subset function, again, our data frame is our first argument. Then we have a comma. And then we use, instead of putting a rule, we use a select statement here. So we select, and then we have an equal sign. Remember, this is not an equals because we're actually assigning something here. That's a little bit confusing. We're assigning these values. This can be thought of as a vector. So as you know, when you create a vector in R, you always use the assignment operator. In this case, it requires equals, and this will be in our help function. So I'm actually, because I do think this is very confusing and is a difficult concept to understand, I am going to copy and paste that into here. Keep in mind, when you copy and paste something with quotes, it messes it up. The reason being that R is plain text, and then in PowerPoint, it is not plain text, it's formatted. So it causes problems when you copy and paste. So just FYI, that is a problem and it's something you should be aware of. If you see white around it, that means that that is the case. So you've seen me do something like this many times. So we, in this case, are setting select equals to these values. So I told you that equals is equivalent to this. So let's run that. Now let's print select. So what it is doing, you'll see that it's now just a standard vector. What this is doing is actually assigning these values to select within the subset function. There is no way to know this syntax. I'm explaining it, but there's no way to know what the syntax is without checking. At this point, it's second nature to me, and I have it memorized, but you guys would not. So in this case, if you wanted to use the subset function, just look it up. In this case, it's going to be the base R. Look in here. So it's telling us the subset, and it's telling us you can use select. So select expression indicating columns to select from a data frame. Now, if you don't know what that means, you can go down here, and it's going to, at some point, it has this. And it looks like you can actually keep quotes out of it, so that's good to know. So it's selecting variables. It's also showing, and I didn't know this until right now, that you can do a rule and you can do a select function inside of the subset. I did not know that you could do them both at the same time, so that's cool. I did not know that. All right. So subset, I think you can also use quotes here, but I'm not sure. So in this case, I actually didn't. So we have our development data, and we are subsetting. So country, corruption percentage score, and corruption rank, percent rank. So we are subsetting world DF to only these three variables. So now we only have 3 columns left. So this, and then so when I put this back up, I will remove these. I do think it does work though, but they're not required. So we are subsetting our data to these 3 variables, and we've checked it by looking at those number of columns. Say we wanted to check one more thing, just the column names, we could do that here, and it would tell us what the column names are. So that's one thing that is pretty useful as well. We are going to learn more about that in the next intro class.